Welcome everyone. My name is S.Sathwik from CSCD second year. Today I would like to explain about Krushkal'S algorithm in this video. Let's get started. In order to know about Krushkal'S algorithm, first we have to know what is a spanning tree. Let's see the definition. A spanning tree is a subgraph of an undirected connected graph. Okay. So first suppose we have a graph. The minimum number of edges required to visit all the vertices of the given graph is called a spanning tree. Now let's discuss about a minimum spanning tree. Minimum spanning tree. Let's see the definition. Minimum spanning tree can be defined as a spanning tree in which the sum of the weights of the edge is minimum. We know that what is spanning tree now. For a graph, there are different types of. There are more spanning trees. In these spanning trees, the minimum cost required to visit all the vertices is called a minimum spanning tree. Now let's discuss about what is Krushkal'S algorithm. Now let's look into Krushkal'S algorithm. By the definition, Krushkal'S algorithm is used to find the minimum spanning tree for a connected weighted graph. The main target of the algorithm is to find the subset of edges by using which we can traverse every vertex of the graph. Okay, here is a note point. First, in order to find the minimum spanning tree, we have to consider the graph must be in connected and weighted. Now let's look about Krushkal'S algorithm. In Krushkal'S algorithm, we start from edges with the lowest weight and keep adding the wedges until the goal is reached. Until the desired vertices is reached. Let's look at the steps to implement Krushkal'S algorithms are listed as follows. First, we have to sort all the edges from lowest weight to highest weight. Now take the edge with lowest weight and add it to the spanning tree. If the edge forms a cycle, then we have to discard it. We have to reject. Next one, we have to continue add the edges until we reach all vertices and thus we can produce a minimum spanning tree. Let's understand this example with an easy example. Let's understand this algorithm with an easy example. Here there is a scenario given. A cable company want to connect 5 villages to their network, which currently extends to the market town of Avonford. What is the minimum length of the cable needed? Okay, here is the problem. Let's draw the diagram for understanding. First, here Avonford is the main city where we have to establish a connection between these cities. Let us consider the 5 villages. I am taking Brindley, Cornwall, Fingley, Donster and Aden. Now let's do this one. Let's consider villages as A, B, C, D, E and F. Next, let's start this. First, we have to select the shortest edge, which means here ED is the shortest edge. Next one, we have to connect the next shortest, in ascending order. Okay, next one be AB 3, next one A to E 4, next one C to D 4, B to C 5, E to F 5, C to F 6, A to F 7, B to F 8 and C to F 8. Yeah, we have listed all the shortest edges. We have listed all the edges in ascending order, which means from the shortest to highest edge. Now let's solve this. Next one. Next we have to add the shortest edge to the spanning tree. Okay. Now see in the figure below, I have mentioned all the spanning trees. All the edges from cost lowest to cost highest. First we have to connect the shortest edge, which means ED. Let's see in the figure. I have connected the ED. Next one, we have to connect AB. See in the figure, I have connected the AB. Next shortest edge is A to E. Okay, now I am connecting the edge A to E. You can take A to E and CD both have the same value. You can take AE or CD. Now first I am considering the value CD. I have connected the CD. Next one, C in the figure I have connected CD. Next I want to connect A, so I am connecting A. C in the figure I have connected it. Next I want to connect BC. Look at here, I am connecting BC, which means these are forming a cycle. In Krushkal'S algorithm, if an edge forms a cycle, then we have to discard it and we have to move to the next corresponding edge. Now I am moving to the next corresponding edge, which is EF 5. Yeah, okay, I think we visited all the vertices. Yeah, we have visited all the vertices. So yeah, this completes the minimum spanning tree. Now let's look at the cost required to complete this minimum spanning tree. From the edge A to D2 and A to A to B3 and A to E4 and C to D4 and E to F5, which is the minimum spanning tree cost of this graph is 18. In this way we can solve the problems using Krushkal'S algorithm. Yeah, this is all about what is Krushkal'S algorithm and its example. With understanding this the example. Yeah, thank you.